Good morning, guys. All right, so today we are going to dissect the unit circle. So the first thing I wanted to talk about is our unit circle and the degrees, okay? So the coordinate plane, which is our y-axis and our x-axis, we've been dealing with. We've been graphing on our coordinate plane. So we know that if we go halfway, it's going to be 90 degrees. Remember, a straight line is 180 degrees, so half of that is 90, 180. If we add another 90, we get 270, and then we get all the way back to a circle, which is 360. So we're going to separate this. If I cut 90 in half, I get 45 degrees, okay? If I cut this 90 in half, isn't that just 90 plus 45? So I get 135. Okay, that 135 plus 45 is 180. The 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. And 315 plus 45, I get back to 360. Now, if I were to separate this 90-degree angle into three sections, so the orange sections, I would get 30, 60, 90. Okay, and you keep adding 30. This is 120, 150, 180, 210, 240, 270, 300, 330, 360. So that's adding by 30 degrees. Okay, so these are the degrees of our unit circle. The next thing I want to talk about is our radians. Let me zoom out a little bit. Okay, these are the radians, and I'm separating it into fourths. Okay. So if we look at the top half, I've separated it into four sections, okay? So for my 45-degree angle, that's 1 pi over 4. This is 2 pi over 4, 3 pi over 4, 4 pi over 4. If I add another section, that's 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. So what we know is half of the circle is equal to pi. So a whole circle is 2 pi's put together, and we get 2 pi. Okay? Now you could find this from our previous homework where we actually transition 45 degrees. How do I change a degree to a radian? Times pi over 180. Okay, so that is pi over 4. Okay, there's 4 45s and 180. All right, now if we were to split it into sixes, okay, so here's 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, 7, 8, 9, 10, 11, 12. Okay, and we always want to reduce. So 2 pi over 6 reduces to pi over 3. 3 pi over 6, pi over 2. Look at my 180. 6 pi over 6 is just pi. Let's look back again. Here, in fourths, isn't 4 pi over 4 pi? Okay, so it's the same whichever way you want to do it. Okay, Now here is all of our degrees on the unit circle, okay? In the maroon color, I have all of my radians written out. And you can find those by just doing the degrees times the pi over 180 to get your radian, okay? Or you could separate it and say, oh, I know this is 1/6. I know this is 2 over 6, 3 6, 4 6, okay? And around. Either way, you can get the information. So we want to start creating this unit circle for us to use, okay? Now, once you have the degrees and the radians, I want to talk about our trig functions and how that relates to our unit circle. All right, so with the unit circle, our radius is always going to be 1, okay? So if we were to do this, if I went over 1, I didn't go up or down, so it's 1 0. From 0 0 and I go up 1, Now I'm at 0, 1. Over here, if I go left 1, it's negative 1, 0. And here, I'm going to go down 1, so it's 0, negative 1. So that's just our coordinate plane, how we graph our points. So if we look at this, okay, triangle, and I drop it down, I can make a right triangle here, okay? So however many this is, it's x values, because this is my x-axis. However high this is my y, because here is my y-axis. Okay, so this is x, that's y, and remember, our radius, no matter where we are on our circle, is always going to be 1. All right, so now we're going to look at sine and cosine. So the sine of theta, okay, this is theta right here, would be opposite over hypotenuse. So opposite is y over 1. So y over 1 is really only y. Okay? Your cosine, let me zoom in for a little bit. Right here. Okay, your cosine is your adjacent. So I'm at theta, my adjacent is x over the hypotenuse, which is 1. So x over 1, which is x. Okay? So therefore, our xy values of our chart is our cosine theta, comma, sine theta. Our x cosine and our y is sine. So this is going to be cosine theta, sine theta. Okay, we're going to replace our x and y with those two. Now, before we move on, I did want to talk about the tangent of theta. Okay, so remember, so, ka, toa. Okay, so if sine is y over 1 and cosine is x over 1, well, tangent, okay, that's just going to be y over x. Okay, so you can also write it as sine over cosine. Our cosecant theta is going to be 1 over y because that's just the reciprocal of our sine. Our secant theta is our reciprocal of our cosine, so it's going to be 1 over x. And then our cotangent is going to be the reciprocal of y over x, so now I have x over y. All right, let me zoom out. So now that we understand those, we are going to talk about our 45, 45, 90 degree special triangles, okay? So if I go up to 45 degrees, that means this angle right here is 45 degrees. Well, on a unit circle, if this is 45 degrees, I know this is 45 degrees as well. So now I have a 45, 45, 90 triangle, okay? Now, I want you to think back to our notes that we took on our foldable. Do you remember these and our special triangles? Okay, so all we did was make a chart and we said, okay, the sine of 45 is 1 over the square root of 2. Remember, you can't have a square root of 2, so I have to get rid of it by multiplying the top and the bottom by the square root of 2. So sine of 45 is square root of 2 over 2. Cosine of 45 is square root of 2 over 2. And the tangent is 1 over 1. All right, so if we go back here, and we're talking about the 45 degree angle. Okay, so all I did was I redid my little triangle, okay, and I'm finding the cosine of 45, okay. You can choose whichever. The cosine is the adjacent over the hypotenuse, 1 over square root of 2. Get rid of the square root of 2, you get square root of 2 over 2. The sine of 45, okay, opposite, which is 1 over the hypotenuse, which is square root of 2, is also square root 2 over 2. So the cosine and the sine are the same for the 45 degree angle, and that is how we find our x and y point here. Okay, this is my x, my cosine. This is my y, my sine. All right, for the 30, 60, 90 triangle, okay, I did both of these on one. So here's my 30. If I know this is 30, I know this one is 30. So that's my 60, 90. This is my triangle, okay? So when I do the sine of 30 and the cosine of 30 of my triangle, Okay, sine of 30, so if I'm at the 30, opposite over hypotenuse, 1 over 2. The cosine of 30 is adjacent over hypotenuse, which is square root of 3 over 2. So my point for my 30-degree angle is cosine, comma, sine. So I have the square root of 3, comma, 1/2. Okay, for 60, I'm going to do the same thing, cosine and sine. So the cosine of 60, if I'm standing at the 60, cosine is adjacent over hypotenuse. The sine is opposite, square root of 3, over hypotenuse. Okay, so again, my point is my cosine theta and my sine theta. So I have 1/2, comma, square root of 3 over 2. Okay, so this is how we find our points. Now, I do want you guys to create your own unit circle, okay? So this is everything on one. I have my degrees, then I have my radians inside, and then I have my points, my cosine and sine. So what I want to show you, let's look at the top half first, okay? So I found the cosine of 30 and the sine of 30, the cosine of 45 and the sine of 45, the cosine of 60, sine of 60. These are the only three that you have to know how to get, okay? Because, now think about when we graphed, okay? Here is our 0, 0. Over here is 1, 0. We go up 1. Okay, so this is just a reflection on this side, okay? So if I think about my x values are positive, my y values are positive. If I go over the y-axis, the only thing that changes is my x value becomes negative. Okay, so do you see how that's a reflection? Only my x went negative. This one's a reflection. Only my x is negative. This one's a reflection. My x is negative. Now, if I'm in this quadrant and I reflect down, okay, so this is a reflection of this one. So now my y actually from 0, 0, now I'm negative and negative, so both are negative. Okay, that's a reflection of this one, both are negative. This one's a reflection of that one, both negative. And if I go over here, remember 0, 0, these are my positive x's. Now my x's are positive and my y's are negative. Okay? So I really want you guys to be able to recreate a unit circle, and that is what I need you guys to use for our homework problems. Now, our homework problems, I'm going to walk you through. All right, so here is the notebook that I want you guys to keep. Okay, so I want to do 10 through 13 with you, and then you guys can do 27 through 30. Use the unit circle to find the exact value of each trigonometric function. All right, so we have sine of 150 degrees. So if I were to look at my unit circle, and you guys can have your unit circle in front of you, okay, I'm looking for 150 degrees. So if I go 30, 60, 90, 120, 150 is right here. 150 matches my 30, doesn't it? And what happens when I reflect over the y-axis? Only my x goes negative. Okay, so now our points are cosine and sine, and it's only asking me the sine of 150. So the sine is 1/2. Okay, number 11. Okay, remember SOHCAHTOA. So I need my tangent now. Remember, your tangent is y over x. Okay, so my y over x is going to be for 315 degrees. Hold on, let me bring it over here. Find your 315 degrees. Okay, y over x. That's where I got those from. So y over x, how do we get a fraction out of a denominator? You're going to multiply by the reciprocal. Okay, so then their denominators cancel, and now we just have this problem up here. Okay, so we have negative 2 square root 2 over 2 square root 2. Well, those cancel, and you're left with a negative 1. So negative 1 is our answer for number 11. Number 12, it says, well, what is the cotangent of 11 pi over 6? So again, we have to go find on our unit circle where 11 pi over 6 is. Well, here it is. Okay, and I have my x and my y. It wants cotangent. Okay, so if tangent is y over x, cotangent is a reciprocal, which is x over y. Okay, so at 11 pi over 6, I'm going to do my x over my y. My x over my y. Get rid of the fraction in my denominator. We get the negative 2 square root 3 over 2. The 2's cancel, and I'm left with negative square root 3. Okay, and then our last one, the cosine of 2 pi over 3. Okay, so you're going to go back to your unit circle. Where is 2 pi over 3? It's right here at 120 degrees. Okay, and we want the cosine. So remember, the cosine is always your x value. So we are going to have negative 1 over 2. All right, I hope this helped you guys. Good luck.